All right, thank you, Professor Bernstein, for the introduction. So, hey everyone, my name is Alok Mysore, and I just graduated with a master's from UC San Diego, and where I work with Professor Philip Goh on HCI research. So I'm applying for a PhD about a year down the line. So, woohoo! So for those of you who are here looking for an exciting presentation on like either crowds or AI, I'm really sorry to disappoint that my presentation is on neither of those. So about a year ago, I was on the same stage in Quebec, Canada at UIST 2017, presenting my paper on generating technical tutorials by operating system-wide activity tracing. This was a system that we called Porta, and Porta enabled creating quality tutorials super easily. But there's already millions of tutorials that are already out there, as Professor Bernstein mentioned a few minutes ago. And we wanted to see how we can improve those tutorials. So we first looked at the tutorials that already exist. So for one thing, a lot of them were obsolete, either because they had differing computing environments, such as like differing operating systems, or they were obsolete because of version replications and things like that. The second thing to note was there was usually no usage data. And when learners had problems that they found in the tutorial, there was no way that they can like communicate that to the creator of the tutorial, apart from writing that in a comment section that nobody might ever see. The third and the most important point over here is that a lot of times seemingly proficient authors created tutorials that were too high level for the learners to understand. So this is super common in the computer science world, where like very common command line tools like cat or grep, which are understood by experts, are points of difficulty for people who are new to it. And this is what we call the expert blind spot effect. So with this project and with this system, we wanted to see if we can give instructors effective feedback about learner behavior. So to give you a bit of context about my own investment in this project, I was TAing this Introduction to HCI course, which was also the one that Professor Bernstein created. And we had a lot of material that already looked like this. And we had almost absolutely no idea on how users were using them. We didn't know if people were actually following these, or if they were going to Stack Overflow, or they were using these to sort of index through Stack Overflow. We had no idea. So we wanted to be able to record these learners looking at our tutorial and then sort of like visualize it on top of the existing tutorial. And this is why we built our system, which we call Porta, which is short for Profiling Operating System Recording for Tutorial Assessment. So Porta is a system to record learners while they look at the tutorial and perform actions on things like IDEs, terminals, text editors, browsers, etc. And then visualize all of this data on top of the existing tutorial so that creators such as myself can gather insights from this. So firstly, what do we want to record? So this is typically the use case that we saw. So a learner usually looks at a browser where there's a tutorial and then performs actions on either an IDE or a terminal or a text editor, etc. So we want to record them while they follow the tutorial on the tutorial webpage, which we call the browser events. And we also want to record the actions they took while following the tutorial, which we call the system events. So when we look at browser events, we want to look at them opening all web pages. So for example, if the tutorial did not have enough context on the grep tool on the command line, they might go to like Google and like search for it. Or if they want to see how the iterators on Python work, they might go to Stack Overflow for that. We also recorded them playing or pausing embedded videos on the web page. And we also wanted to figure out the learner's focus area without having to invest in like expensive eye tracking gear. So how do we figure out what the learners are focusing on? So in this example tutorial that you see here, the learner has their cursor on a block of code, a block of hello world code in Java. And there's a pretty good probability that the learner is looking at that block of code right now. But there's also a good chance that they were looking outside where the mouse is pointing. And in all likelihood, they're looking at the center of the page rather than the edges. So if we add both of these components, we get like an approximation of the user focus. And in our experience, this was actually pretty accurate. It was not 100%, but it was actually really accurate in terms of what the user was looking at. When you look at system events, we recorded all of the learner's screen while they performed the actions and followed the tutorial. We also recorded them copy-pasting things and other clipboard actions. For web-specific tutorials, we recorded them opening the Chrome developer tools and also JavaScript errors that occur on the browser. We also, the last parts that we recorded were them running certain terminal commands and also toolchain actions such as GCC, make, javac, etc. And this worked both on their own local machines or if they SSH'd into a remote server where they were following a tutorial. So you might ask, why do we record toolchain actions separately from just terminal commands? Isn't running GCC just through the terminal? Can't we just do something like that? So we want to record these things separately because oftentimes, if you were using an IDE such as Eclipse or PyCharm or something, these binaries such as javac, make, etc., are invoked by the IDE and not the terminal. So we want to record those things. We also want to log the source code that was compiled by these toolchain binaries. And we also want to record things like stdin, stdout, stderr files. So what we built essentially was a shim that replaced the original binary in the $path variable. This shim was essentially this shim was identical to the original binary, and internally it invokes the original binary itself. The only difference is that it logs the command line arguments, the standard input, output, and error files onto a log file. You also see that we also attach a dtrace monitor to the original binary. So let's go through an example of why we need this. So suppose the learner is going through this particular Java program with two files, client.java and lib.java. Suppose client.java imports certain functions from lib.java. When compiling, you usually do something like javac client.java. But just inspecting the files in the command itself does not give us a complete idea of the program. We have no idea to figure out that lib.java is also included, and we have no way for us to figure out what was in lib.java. So we attach a dtrace process to the javac shim, and essentially what it does is it reads every file that was read in by the javac shim. And this lets the creator of the tutorial see every file that was ever compiled. And again, this is a very trivial example. This also allowed us to see things like configuration XML files and data JSON files and a lot of other things. So once we have all of this data, we obviously want to visualize this. There's no point of having the data if you can't see it, right? We want to answer questions like, where in the web page did a particular event happen? We want to answer things like, when did a particular event happen? And also we want to be able to filter events based on things like between certain time periods or between certain subsections of the tutorial, or to filter events by their types. So this was the UI that we envisioned for our visualization. We see the original tutorial webpage. On the left, we see a positional heat map for the user's focus area that we discussed earlier. On the bottom, we see a temporal heat map for the events that are based on time. The event icons are laid out both on the positional heat map to denote where in the page they occurred, and on the temporal heat map to show when in the tutorial they occurred. And on the right, the creator can like filter events by their event type, and there are also temporal and positional range sliders to filter events based on time or to particular subsections of the tutorial. And this is kind of how it looked when it was implemented. So when the creator clicked on a particular event icon, you get a pop-up with more details about the event. For example, in this case, you see the working directory and the return code, etc. So now that we have this system built, we wanted to see if Porta can firstly enable learners to reflect on the difficulties they faced while following tutorials, and also to see if instructors could gather useful feedback to improve their tutorials. So for the evaluation, we used real-world tutorials. The first one was a Python tutorial, which is a primer on types, control flow, and functions. It was used in two iterations of a 400 student data science course. The second was a web design course, which was an introduction to HTML, CSS, and JavaScript, which was used in 4 iterations of a 300 student HCI course. The last was an introduction to Git and GitHub, which was used in a 10,000 student online course. So we recruited 4 undergrad learners for each tutorial, which is about 12 learners in total, 9 female and 3 male, for about 1 hour each. All of them had little to no experience in the subject of the tutorial. So first, the 4 learners look at one particular tutorial. They then reflect on the difficulties and the improvements that they can make to the tutorial, initially before seeing their own Porta visualizations, and afterwards while seeing their Porta visualizations. We then had the instructors look at the recordings for those 4 learners. And then the creators reflected on the improvements that they would make to the tutorial, firstly before seeing the 4 recordings, and while seeing the 4 recordings. So this was an overview with all 3 tutorials. And for the learners were actually had feedback after they saw their Porta output. So 8 of 12 went from something like it's good enough in its current state to having actual feedback. The learners gave very specific feedback. They went from something like the language could be more noise friendly to use different formatting for text and commands, or something like need more Windows specific advice to explain how the cat command was used here. The learners also gave targeted feedback about where in the tutorial page they wanted the improvements. So for example, one of the learners mentioned that the tutorial ought to mention that the variable in a Python for loop is the value in the loop and not the index, like in Java. And for the instructors were able to overcome their own expert blind spots. All 3 instructors noticed unexpected student behaviors that surprised them, and this was despite these tutorials having been used multiple times in the past. The instructors also came up with very, very specific improvements. The instructors went from something like update this tutorial for Python 3 to talk about starting code blocks with colons and indentation in Python. So this is a high-level overview of the impact of the study. With just about 12 learners, 3 instructors, and about 5 days, we were able to solicit 28 unique improvements from the learners, as denoted by the pink arrows in these 3 images, and about 27 improvements by the instructors, shown by the green arrows in these 3 images. And again, just to reiterate, this was on tutorials that had been used extensively in the past and had been iterated over multiple times. So to summarize, we built Porta, which is a system to record learners as they use tutorials across multiple applications, including IDEs, terminals, text editors, etc., and then visualize all of this data on top of the original web page. The learners were able to better reflect on their struggle while using these tutorials, and the instructors were able to gather more actionable feedback for the tutorials. I'd love to answer any questions that you guys have today.
Please step up to the mic with your question.
Hi, I have 2 questions. First, I read a little bit later, so I don't know if you talk about the method. How did you validate that using the mouse and the scrolling is actually showing user focus, because focus is also different than attention? And also, did you run a study using eye trackers to see the comparison of the results that you can get with eye tracker when you measure gaze and when you're selecting this method that you selected for the particular study?
To answer the question, no, it was not a very formal study in terms of the accuracy of the eye tracking. But what we saw in our experience was that the positions where people actually spent time was where it was highlighted in the tutorial. Where they were actually looking at, that was where it was located, yes.
So you didn't even ask the users if they were...
Yeah, and the learners also agreed that this was actually where they were looking at, but it was not a very formal study.
Okay. Thank you.
Thank you.
Hi. While the focus of this work is for improving the tutorials, was there any case or examples when watching one's learning pace again helped students learning?
That's an interesting question. We did not try that out, but that would be an interesting future work to see if that looking at their profile actually helped them learn better. Thank you.
Thank you.
Hey, hello, Carsten Zay from Google. Thank you very much. This is a very interesting presentation. I have two questions. One is, did you run a follow-up study to see about the efficacy of the proposed changes? So you say, hey, we improved stickiness of learning by, say, 30%. And the other is, do you have any funnel diagrams or so that you could deduct from the typical path of doing a tutorial? For example, do you see everybody starts in the browser, then to the IDE, then twice Stack Overflow, back to the browser, something like that?
To answer your second question, I'm sure we should be able to visualize that from the data that we have, but we have not done something in that regard so far. Could you repeat the first question again?
I think the first was about the efficiency of the improvements that were made with regards to the feedback that was gotten by tracking the ideal user flow. Yes.
So we actually did have a study on that, which I did for another course while I was at UCSD. The improvements that were made were actually impactful in terms of it did improve what the learners thought they saw initially. But unfortunately, we could not include it in this paper because it was past the time, and I did this for a different course.
Yes. No, I totally understand, but I think it would be super interesting to see that there was any quantifiable data to say, hey, people now require 20% less time and are 10% more knowledgeable about whatever has to be taught.
Okay.
Thank you very much.
Thank you for the great questions.
All right, let's thank the speaker. Congratulations. So this concludes the session on things that are not AR, VR, or fabrication. Thank you for joining.